for this unit. It's called 11.4, where we're going to be learning about one more new formula called the ideal gas law, or one more. Okay, so let's talk about the ideal gas law. So this law only works for ideal gases. What's an ideal gas? An ideal gas is a gas that follows all 5 of the kinetic molecular theory rules, okay, which we talked about on our lecture day. Remember that gases have to be spaced out and far away. We know that gases have to be moving quickly and randomly. We know that gases have elastic collisions, right? So they bounce off when they collide into other gas particles. We know that there's no attraction and repulsion force between the gas particles. We know that temperature is directly related to its energy. So those KMT rules that we talked about, if the ideal gas meets all of those rules, we say it's an ideal gas and we can use this formula. Okay, so let's talk about each of these. Well, P stands for pressure. And in our lesson, whenever you're using the ideal gas law, you have to have a particular unit for pressure. It always has to be ATMs. If you're given any other unit, what do you have to do? Convert it. Okay, V is going to stand for volume. And volume in this formula is going to be always in liters. So if they ever give you milliliters, you better convert that sucker to liters fast. Because if you use milliliters, you'll get a weird answer. And now we have a new unit, which happens to be with the letter N, which doesn't stand for new unit. It actually stands for moles. Why do they not have moles start with an M instead of an N? I will never know. Actually, I do know. N stands for number of moles. That's what it stands for. And guess what the unit is for N? Moles, duh. Okay, now we come to this R. What's up with the R, dude? R is known as our gas law constant. Gas law constant. Our gas law constant is a number that will always stay the same. R will always be 0.0821. Okay, it's a constant that we have to use in this formula. So anytime you have R, it's 0.0821. And our last one is T, which obviously stands for temperature. And again, this isn't new, but temperature should always be in what unit? Kelvin! Always in Kelvin. So guess what happens if you're not given any of these units? You have to convert. For example, what happens if I give you millimeters of mercury instead of ATMs? You have to convert. What if I give you milliliters instead of liters? You have to convert. What if I give you grams? You have to convert to moles. What if I give you Celsius? You have to convert to Kelvin. Every time you have to have those units. So let's get started. Let's dive right on in. So I wrote out these 4 steps to solving the ideal gas law problem. I would be so honored if you'd write them on your page. So number 1, label every given in the problem. If there's one of each variable, like one pressure, one volume, one temperature, then it's ideal. If there's 2 of the variables, like 2 pressures, 2 volumes, 2 temperatures, 2 pressures, then we'll use combined. The only exception is if they only give you pressure and they're talking about partial and total pressures, then they're not talking about the combined gas law. They're talking about Dalton's law, where it's PT equals P1 plus P2. So let's look at our guided practice. Label all our givens. So 0.63 moles. What is that? Well, we just said moles was N. So I'm going to label that as N. Okay, 3.8 L. What is L? L is volume, so I'm going to label that as V. The temperature is 25 C. And you know what? We always need to check and make sure they're in the right units. Moles is the right unit. Liters is the right unit for volume. But Celsius is not the right unit for temperature. So I'm going to stop right now. I'm going to put T equals. Does not equal 25. How do I get from degrees Celsius to degrees Kelvin? Or to Kelvin? If you forgot, you need to rewatch 11.1. But we add 273. Okay, so when I do that, I get 288. Okay, so I have temperature, I have volume, and I have moles or N. Okay, And it's looking for, it tells me right here, what am I looking for? I'm looking for pressure. And notice I'm not putting 1s and 2s because there's no change, right? They're all 1s. They're all before a change happens because it's at one condition. The condition's not changing. So I'm going to plug them in. So here's my, check your units and convert. I kind of already did that. Pressures, remember, has to be in ATMs, volumes in liters, temperature in Kelvin, and N has to be in moles. So everything is right. I'm looking for my pressure, and it's going to be in ATMs, right? It's going to be in ATMs here. So, and remember, we're always given R, right? We're always given R. So let's plug the givens into the formula. So let me write out my formula again so you can see it. PV equals NRT, nRT. P we don't know, so I leave it as P because I'm looking for that. And all of these variables are being multiplied by each other, so I'm going to put brackets here for my volume. My volume is 3.8. My N was 0.63. My R is always 0.0821. And my temperature, remember, I converted it, so I'm not using 25, I'm using 288. So now I simplify. Always simplify your numbers. So I'm going to multiply all of these together. Okay, so I'm going to get one number. You don't want 3 numbers when you can just have 1. So when I multiply them, I get 14.896. So I'm going to round up to 90. Here we go. And then on this side, I still have P times 3.8. So how do I get P by itself? Well, I have to remove 3.8 to the other side. How do you do that? If you divide both sides by 3.8, then it's gone on this side, right? We don't have it. So really, we have P equals 14.90 divided by 3.8. And when I put that in the calculator, I get 3.92. So what's my unit here? 3.92 what? Well, remember, pressure always has to be in ATMs for the ideal gas law. Not for any of the other ones, but for the ideal gas law, it has to be ATM. So I write ATM. And that is my final answer. Okay, so let's look at number 2. It says, what's the volume of a balloon if it takes 32 grams of helium? So I'm going to stop and look at grams. Now, what is grams? How is that going to help me? Well, we did talk about how everything has to be in the right units, right? Well, a wrong unit for N could be grams. So if they give you grams, you would just need to convert to get to your moles. So let's go ahead and do that. I'm kind of doing number 1 here and number 2 together, the steps. I'm doing, I'm labeling, but I'm also converting my units as I go. Okay, so let's do that. Okay, so 32 grams. That's supposed to be N, but it's the wrong unit. So let me change it right now. N equals. How do we convert? You always put your given over 1 every time. Okay. Now my given unit is also going to go on the bottom. The unit I want to go to goes on top. I want to go to moles. Now, what's the conversion between moles and grams? And this is something we learned a while ago, but it's always molar mass, okay? 1 will always go next to the mole, and then molar mass will go next to grams. So I have to find the molar mass of helium, which on the periodic table, it's 4.00. So when I do that, 32 divided by 4, I'm going to get 8 grams. Not grams, sorry. Grams cancels. I'm in moles now. So this is 8 moles of helium. So I have N. Now let's look at my other numbers. It's at a temperature of 20 degrees C. So that's temperature. However, it's the wrong temperature, right? So I need to convert. Okay, so temperature is not, it's not 20 degrees C. We have to convert it to Kelvin. So it's really 293. That's my temperature. So we have N, we have T, and we have P, pressure. What is standard pressure? Standard pressure is always 1 atm. Okay, so I have N, I have T, and I have P. So here's my formula, PV equals nRT. I have N, I always have R, I have T, and I have P. So what am I solving for? V, and I can tell that because it says what is the volume. That's what I'm solving for. So let me plug in my numbers. Pressure is 1, we just talked about that. Volume is what we're looking for. N is 8. R is always 0.0821. T is 293. And then simplify. So I'm going to multiply all of these together so that I get one number on the right-hand side, okay? and I get 192.4. Remember, I still have 1 on this side and then B. If I have 1 on the left and I divide both sides by 1, I still get the same number. So V equals 192.4. Now, what's my unit here? Volume was always going to be in liters when we use the ideal gas formula, so it'll be 192.4 liters. Okay, so we have one more problem I want to do with you. And this is going to require us to convert just like the other ones did. So you always got to watch out for those units. So first thing we do is I label. So kPa is a unit for pressure, but it's the wrong unit for pressure. So I'm going to convert. I had 123 kilopascals, but what unit do I want? Well, I want to go to ATMs because pressure in my ideal gas law always has to be ATMs. So kilopascals goes on the bottom. And what's my conversions? Well, 1 is always ATM and 101.3 is kilopascals. If you have issues converting, you need to go back and rewatch 11.1. I'm dividing, and I get 1.21 ATMs. So that's my pressure. Okay, I have pressure. My volume is in liters, so that's good. I'm looking for temperature. And I have 16 grams. So N is in grams. Is that the unit N has to be in? No. N is supposed to be in moles. So I have to convert 16 grams of gas. I'm going to moles. So moles goes on top. I'm trying to convert out of grams. So grams goes on the bottom. What gas am I doing? Oxygen gas. Okay, so oxygen gas is actually O2. So instead of doing 1 oxygen, I'm going to do 2. There's the molar mass of 2 oxygens. I divide that. If I do 16 divided by 32, I get 0.5. So that's moles. So here's my formula. PV equals nRT. What do I have here? There I have my moles. Okay. Here's my pressure. Here's my volume. I always have R, so I'm looking for T. So let's plug in those numbers and solve for T. So pressure, like I said, was 1.21. Volume is 10.0. My moles was 0.5. R is always this number. And then I'm looking for T. So always simplify, 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 simplify. So I'm going to do 1.21 times 10, which gives me 12.1 on this side. I'll simplify the numbers on the other side by multiplying them together. And I get 0.0, whoopsies, 0.411 times T. So now to get T by itself, I got to divide both sides by this 0.0411 number. So I'm going to do that. Sorry, it's hard to see. So I'm going to write down here. That cancels. When I divide this side, I'll do 12.1 divided by 0.0411. And I get 200, so T equals 294.4. And then my unit for temperature is always Kelvin. And I'm done. So I want you guys to try this on your own problem. And then I really want you right after this to start on your skill check, because the skill check has you practicing all the different laws. Remember, Dalton's, combined, and the ideal one has you practicing all of them. Remember, the easiest way to mess this up is to not convert. So just make sure everything's in the right units, and you'll be dandy. You'll be good to go. You'll be G2G. All right, that is it for your last video on gas laws. You'll have a wonderful day, whether you're on spring break or whether you're coming back from it, and I will catch you on the flip side. Adios.